For the vast majority of human history, our cardiovascular system was shaped by high daily caloric expenditure and minimally processed diets. This network evolved under the pressures of an agrarian existence, a reality that has vanished in a single century. We have replaced mandatory physical labor with a sedentary modern reality, creating a deep mismatch between our biology and our environment. By 1950, this mismatch reached a crisis point. The age-adjusted death rate for cardiovascular disease peaked at 307.4 per 100,000 people. At that time, a heart attack was fatal in 1 out of every 2 cases. Over the next 5 decades, medicine launched a successful campaign against this mortality rate. Surgeons developed bypass grafting and balloon angioplasty, while cardiologists deployed stents to ensure the large conduit arteries on the surface of the heart remained propped open. These mechanical interventions contributed to a 75% reduction in deaths. But recently, that progress has stalled. After decades of decline, cardiovascular mortality in the United States is climbing again. In many of these modern cases, the large epicardial arteries, the major pipes seen on a standard angiogram, are perfectly clear. The failure is occurring beneath the surface, in the microscopic web of capillaries responsible for the actual delivery of oxygen to the myocardial tissue. The surgical tools that addressed macro-level obstructions are unable to detect or treat the cellular decay now occurring within this microscopic network. This microvascular decline tracks with the industrialization of the American food supply. The transition to globalized, shelf-stable logistics introduced ultra-processed formulations that decoupled human sustenance from its natural, fibrous architecture. This chart shows the resulting quantitative surplus. Between 1909 and 2010, the total available daily calories per capita rose by 18%. When adjusted for food loss, actual consumption still saw a 22% increase since the 1970s. While the diet-heart hypothesis blamed animal fats for the mid-century epidemic, retrospective data shows a different trend. Per capita red meat consumption fell by 44%, while the use of chemically extracted polyunsaturated vegetable oils rose by 238%. Metabolic syndrome and microvascular failure accelerated in parallel with this explosion of refined flour, sugar, and industrial oils. This suggests our current cardiac crisis is a biological response to the replacement of stable nutrients with these oxidizable chemical analogs. To understand how these foods damage the heart, we have to look at the endothelium, the layer of cells that regulates vessel dilation and defense. Dietary fructose, a staple of processed food, enters these endothelial cells and bypasses the metabolic checkpoints that regulate glucose. This creates a state of unchecked phosphorylation. As shown here, rapid fructose processing causes a massive depletion of intracellular ATP. The cell enters an energy crisis, triggering an alarm. This activates the PP2A enzyme, dephosphorylating eNOS, neutralizing the pathway responsible for producing nitric oxide, the molecule maintaining a dilated, anti-inflammatory vessel. Without the protective shield of nitric oxide, the vessel's surface becomes adhesive. Circulating immune cells bind to the wall and migrate into the tissue, creating a state of chronic, localized oxidative stress. This dietary toxicity is reinforced by physical stagnation. In modern environments, a significant portion of the population engages in less than 10 minutes of purposeful physical activity per week. This lack of movement removes hemodynamic shear stress. Shear stress is the physical friction of blood moving against the vessel wall, which the endothelium interprets as a survival signal required for its maintenance. Without this mechanical friction, small resistance arteries undergo inward remodeling. The vessel walls thicken and the internal diameter narrows, increasing baseline vascular resistance and forcing the heart to pump against higher pressures, even at rest. The modern lifestyle creates a cycle of decay. Industrial additives poison the endothelial machinery, while the absence of physical movement removes the mechanical stimulus needed to repair it. The combination of dietary inflammation and stagnant blood flow leads to meta-inflammation, a state of chronic immune activation across the heart's microcirculation. This chronic stress triggers endothelial mesenchymal transition. Endothelial cells strip away their specialized vascular markers and transition into myofibroblasts, filling the heart's capillary beds with dense fibrotic scar tissue. This physical pruning of the network is known as macrovascular rarefaction. This process is a primary driver of heart failure with preserved ejection fraction. The heart can still pump blood out, but the accumulation of microscopic scar tissue makes the muscle too stiff to relax and fill with an adequate volume of blood. This microscopic scarring is precisely why cardiovascular mortality is rising despite our surgical advancements. A stent can clear a highway, but it cannot deliver oxygen to a heart where the residential streets have been replaced by scar tissue. However, the coronary microcirculation remains highly plastic and capable of structural change when exposed to the correct stimulus. The reintroduction of physical activity generates immediate hemodynamic shear stress. This mechanical friction reactivates the endothelial machinery, restoring the production of nitric oxide and its associated antioxidant pathways. This stimulus triggers angiogenesis. As shown here, the heart can respond to exercise by constructing new capillary networks, increasing the density of the microvascular web by up to 60% and expanding the surface area for oxygen exchange. This outward remodeling and restoration of the myogenic response can help reverse the structural atrophy caused by sedentary aging, improving the heart's ability to regulate its own blood flow. In a landscape dominated by industrial food and sedentary habits, our survival depends on recognizing this biological requirement. True cardiovascular health requires the continuous mechanical and metabolic nourishment of the vascular endothelium.